The flared end helps to create a seal when the pipe is connected to another pipe or fitting. Flaring is used in a variety of industries including plumbing, oil and gas, mining, and steam systems. Come, let's go into the video.
At the end of this demonstration, you will be able to cut a GI pipe using a pipe cutter, remove burrs using a pipe reamer, flare the end pipe, join flare nut with flare fitting and test it. Tools required: adjustable wrench 200 mm, valve key 6 mm, cylinder valve opener, pressure gauge with adapter, cylinder with pressure, water pump pliers, pipe cutter, hacksaw with blade, tri-square, punch tool. Equipment required: flaring block with yoke, flat file smooth 200 mm, pipe vise. Materials required: GI pipe, flare nut to suit the pipe, thread seal tape, soap solution with stirrer, a small quantity of oil. Before starting job, there are some preliminary checks to be made. Those are as follows. Check the material size and its conditions. File and check that end of the pipe must be exactly perpendicular to the pipe axis. Slightly deburr inside and outside edge of the pipe. Clean the pipe throughout before installing a flaring block. Insert and fix the pipe into flaring block selected hole. Note: examine the pipe flaring tool before starting to flare the end of a pipe. Tighten the nuts at each end of the flaring block properly. Position the pipe end to at least 3.3 mm above the top of the flaring block. Note: this distance is calculated as pipe diameter divided by 3, in this case 12 mm divided by 3, is equal to 4.0 mm. Place the yoke, flaring tool, to the flaring block. Note: insert the flaring nut before flaring. Oil the cone and slowly screw it into the end of the pipe. The end of the pipe will be formed into a flare. Note: do not over-tighten the screws. Unscrew and remove the flared pipe from the block. Check the flare end for cracks. Note: because the cone was screwed down too quickly, flare is cracked. Make sure that the flare is in correct size. If any crack or too loose while fitting flare nut, cut off the flare and start again as per above instruction until the flare is in correct size for the flare nut. Next, we are going to make flare joints and test them with flare fittings. Flaring. Brake line pipes, fuel pipelines, air conditioner pipelines are sometimes joined to fittings by making a flared connection. The end of the pipe is opened out to form a cone. Always place the special flare nut on the pipe first before flaring. Examine the pipe flaring tool. Make sure that you understand how it works before starting to flare the end of a pipe. Make sure that the end of the pipe is free of rough edges before flaring. Place the pipe in the tool. Make sure that you have placed the flare nut on the pipe. Choose the correct size hole in the flaring tool to fit the pipe. There are 5 holes to fit different sizes of pipe. If the pipe is 1 by 4 inch, 6 mm in diameter, Position the pipe so that the end is at least 2 mm above the top of the flaring block. This distance is calculated as pipe diameter divided by 3. In this case, 6 mm divided by 3 is equal to 2 mm. Tighten the nuts at each end of the flaring block. Fit the yoke to the flaring block. Note: repeat the steps to the various sizes of GI pipe. Joining with flare fittings. Put thread seal tape on the thread. Push back the flare nut and place the flared pipe on the fitting. Then, tighten the flare nut using adjustable wrench or suitable double-end spanner. Tighten the one end of the pipe to the cylinder with the flare nut. Connect a pressure gauge at the other end of the tube with flare nut. Note: do not give more pressure while tightening, since this will spoil flare. Make sure that they should not be loose in the pipe. Observation Table 2. After joining the pipe firmly, open the cylinder valve with the help of valve key or ratchet. Note: the pressure will be shown in the pressure gauge. Then close the cylinder valve. Major leaks will make noise, and that needs the nut to be tightened. If there is no leak, the pressure in the pressure gauge will remain constant. If it decreases, check the joints with soap solution foam. Leak will bubble, then tighten the joints. If it stands still, then there is no leak. Now, let's have a look at handling of pipe flaring and cutting tools. Measure the required length of pipe and mark it with chalk. Keep the pipe in the pipe vise and tighten it. Fit the pipe cutter on the GI pipe on the scribed line and tighten the jacking screw so that the cutting wheel is touching the pipe. Note: ensure that the pipe is kept horizontal and parallel to the serrations such that the marking is visible at the top. Rotate 1 or 2 turns to ensure that the cutting wheel is sitting exactly on the scribed line at 90 degrees to the pipe. Rotate the pipe cutter around the pipe. After 2 or 3 turns, use the jacking screw to apply pressure on the cutting wheel. Keep rotating the pipe cutter around the pipe. Increase the pressure to the cutter by repeating the cycle until the pipe is cut through. Support the pipe with your left hand so that the free end of the pipe does not fall. Remove burrs using a pipe reamer. Check that the pipe ends are square. Inside edge of the pipe must be slightly deburred. Outside edge of the pipe must be slightly deburred. With this edge as reference, the pipe is marked for bending. Always use pipe bending fixture for proper bending of the pipe. Clean the pipe thoroughly before installing in the machine. Prepare the pipe end for a flare fitting. Flaring with block and punch tool. Pipe which is cleaned off burrs and bent should be selected. The pipe end is held in the flaring unit. Select the appropriate size of flaring unit to suit the pipe. Sleeve and cap nut should be assembled before flaring. The flaring unit is held in a bench vise with the pipe. Correct length of pipe should be projecting for flaring pipe edges should be in line with surface. Using the flaring punch, flare the pipe end. Flaring can also be done by using a compression type flaring tool. Installing a flare fitting. Flared tube is cleaned and the sleeve and cap nut are positioned on the flare. Check the flare angle is suitable to the sleeve angle. Place the flare on the connector end. Confirm the angle is same. Screw the cap nut on the connector thread by hand. Use a suitable spanner and tighten the cap nut until the pipe does not rotate in the joint.
Let's have a recap of what we have learned today. We have learned to cut a GI pipe using a pipe cutter, remove burns using a pipe reamer, flare the end pipe, joint flare nut with flare fitting and test it. Thus, we have learnt about flaring of pipes and pipe joints. Hope you have a clear understanding on this. Do this exercise with the help of your instructor. Hi, my name is Deepthi. In this video, we will be discussing the cutting and threading of pipe length. This is an important process in the construction of pipe systems, and there are a few things to keep in mind to ensure it's done properly.
At the end of this demonstration, you will be able to mark and cut pipe to length using pipe cutter. Tools required: adjustable wrench 200 mm, valve key 6 mm, cylindrical valve opener, pressure gauge with adapter, cylinder with pressure, GI pipe cutter, pipe vise, equipment required: flaring block with yoke, flat file smooth 200 mm, materials required: GI pipe, flare nut to suit the pipe, wire brush, pipe die set with ratchet, thread cutting oil. Before starting job, there are some preliminary checks to be made. Those are as follows. Hold the GI pipe in pipe vise tightly. Mark the required length as per drawing. Fix the pipe in pipe vise and tighten it to prevent it from rotating. Fix the pipe cutter on the GI pipe. Cut GI pipe for the required length using pipe cutter. Remove burrs using pipe reamer. Check that the pipe ends with tri-square for squareness. Now, we are going to thread GI pipes using die stocks. Select a set of dies and ratchet type die stock. Open the adjustment lever, coincide the 0 setting mark 0 die stock, and then insert the 4 dies according to the number on the dies and die stock respectively. Ensure that the dies sit in the correct position. Note: be sure that the number on the top edge of the die corresponds with the number of the slot into which it is to be placed. Fix the pipe in a pipe vise and tighten to prevent it from rotating. Note: ensure that the projection of the pipe is within 150 to 250 mm from the vise. Open the self-centering pipe guide and slide the stock over the end of the pipe. Adjust the pipe guide for correct sliding, fit, and lock into position. Apply a cutting lubricant to the part which is to be threaded. Note: use lard oil or mineral lard oil when threading GI pipes. Apply a little pressure to the stock and keep the handle at right angle to the pipe axis. When the dies bite into the pipe, stop pushing and continue the rotation by moving the handle up and down. Apply the lubricant to the pipe after the first thread has been cut. Keep rotating the handles clockwise and check the length of the pipe thread. Note: ensure that the length of the thread is sufficient to fit halfway into the socket or coupling. If the die stock and the die stick, turn the stock anti-clockwise to break the chips. Reverse the ratchet knob, ease the handle, and turn the stock anti-clockwise till the stock and dies come out of the pipe. Clean the thread with a wire brush. Form thread until the pipe extends about 1 or 2 threads beyond the end of the stock. Remove the stock and dies by operating the quick release lever and clean off the thread with a wire brush. Check the formation of thread with a standard fitting. Repeat the operation if the thread is too tight by adjusting the dies.
Let's have a recap of what we have learned today. We have learned to mark and cut pipe to length using pipe cutter. Thus, we have learnt about cutting and threading of pipe length. Hope you have a clear understanding on this. Do this exercise with the help of your instructor. Hi, my name is Deepti. One of the most important aspects of plumbing is the fitting of pipes. This is a process that involves connecting 2 or more pipes together in order to create a system that is able to transport water or other fluids. There are a number of different ways to fit pipes together, and the method that is used will depend on the type of material that the pipes are made from, the size of the pipes, and the type of connection that is required. Today, we are going to learn about fitting of pipes as per sketch, observing conditions used for pipe work.
At the end of this demonstration, you will be able to fix the GI pipes with fittings as per drawing. Tools required: Adjustable wrench 200 mm. Valve key 6 mm. Cylinder valve opener. Pressure gauge with adapter. Cylinder with pressure. Pipe cutter. Hacksaw frame with blade. Tri-square. Pipe die set. Water pump plier. Equipment required. Flaring block with yoke. Flat file smooth 200 mm. Materials required. GI pipe. Flare nut to suit the pipe. Before starting job, there are some preliminary checks to be made. Those are as follows. Calculate the length of pipe required based on drawing. Cut the pipes as per the calculated length using pipe cutter or hacksaw. Cut thread at the end of all the pipes using die stock. All the pipes have been measured and has been cut as per the calculated length. Now, let's begin with fitting. Fit T1 to pipe 1 using pipe wrench. Fit the pipe 2 to T1 using pipe wrench after adopting the procedure. Fit elbow 2 to pipe 2 using pipe wrench after adopting the procedure. Fit pipe 3 to elbow 2 using pipe wrench after adopting the procedure. Fit elbow to pipe 3 using pipe wrench after adopting the procedure. Fit pipe 4 to elbow using pipe wrench after adopting the procedure. Fit a socket to pipe 4 using pipe wrench after adopting the procedure. Fit bib cock to socket using pipe wrench after adopting the procedure. Fit pipe 5 to T2 using pipe wrench after adopting the procedure. Fit socket to pipe 5 using pipe wrench after adopting the procedure. Fit bend to socket using pipe wrench after adopting the procedure. Fit socket to bend using pipe wrench after adopting the procedure. Fit pipe 6 to socket using pipe wrench after adopting the procedure. Fit elbow 3 to pipe 6 using pipe wrench after adopting the procedure. Fit pipe 7 and 8 to T3 using pipe wrench after adopting the procedure. Fit socket to pipe 7 and 8 using pipe wrench after adopting the procedure. Fit bib cock to sockets using pipe wrench after adopting the procedure. Remove any excess hem, string or sealing tape after completing the joints using hacksaw blade or a blow lamp. Assemble pipe with standard fittings. Now we are going to assemble the pipe and pipe fittings. Hold the pipe number 2 in a pipe vise. Wind the hem packing or cotton thread material on the external threads of the pipe. Apply sealing compound over the pipe threads. Fit T2 to pipe number 2 and tighten it using a pipe wrench. Note: wind the hem packing to external threads of all the pipes in standard fittings and apply sealing compound over the threads before joining with the other one. Fit pipe number 3 with elbow 2. Fit elbow 1 to pipe number 3. Fit elbow 1 to pipe number 4. Fit a socket to pipe number 4. Fit bib cock to socket. Fit pipe number 5 to T2. Fit pipe number 5 to socket. Fit socket to elbow 2 on both ends. Fit socket to pipe number 6. Fit T3 to pipe number 6, 7, 8. Fit socket to pipe number 7. Fit socket to pipe number 8. Assembling elbow with pipe. Now we have successfully completed the assembling.
Let's have a recap of what we have learned today. We have learned to fix the GI pipes with fittings as per drawing. Thus, we have learnt about fitting of pipes as per sketch observing conditions used for pipe work. Hope you have a clear understanding on this. Do this exercise with the help of your instructor. Your instructor. Hi, my name is Deepthi. Bending of pipes, cold and hot, is a process that is used to change the shape of a pipe. This can be done for a variety of reasons, such as to fit a new shape or to make the pipe easier to transport. There are two main methods of bending pipes, cold and hot. Cold bending is done at room temperature, while hot bending is done using heat. Today, we are going to learn how to bend pipes using hot and cold method.
At the end of this demonstration, you will be able to bend GI pipe by cold method as per template on a pipe bending machine. Bend GI pipe by heating and match with template. Tools required: pipe wrench, tape measure, pipe cutter, hacksaw, pipe bender, tri-square, steel rule, soft hammer. Equipment required: pipe stand, hammer. Materials required: pipes, bending spring. The first method we are going to try is cold bending method. Cold bending of pipes is a process where a pipe is bent using cold temperatures. This can be done using either a cold bending machine or by putting the pipe in a freezer. The advantage of cold bending is that it can be done without having to heat the pipe, which can damage it. Cold bending also allows for more precise bends to be made. The advantage of cold bending is that it can be done without having to heat the pipe, which can damage it. File the pipe ends and check up its squareness. Check the inside dia of the pipe by using steel rule. Please change the reading from inside diameter from 10 cm. Measure the length of the pipe as per drawing.
R is equal to radius of bend. Theta is equal to angle of bend. L is equal to length of curved portion. Then L is equal to pi into d into theta divided by 360. L is equal to total length is equal to L1 plus L plus L2.
Mark off the beginning and the end of the bend from the center line. Select the standard former to suit the size of the pipe. Fix the bending machine in a bench vise and ensure it is tightened properly. Locate the tube stop bar at the required position. Set the roller on the bending arm by adjusting the screw and lock nut. Bend the pipe by pulling the bending arm towards your body. The sleeve bends the pipe round the former as the bending arm is pulled. The backstop holds the tail's end of the pipe in position. Check the bend for squareness, use a set square. Check level of former and first leg 90-degree bend with spirit level by placing spirit levels. Check the angle of bend and radius using standard template. Bending 120 degree by hydraulic bending machine. Fit the pipe former onto the cylindrical arm. Place the pipe between the forming head plates and against the former. Support the pipe and fit dollies or rollers between the upper and lower plates of the forming head. Locate them in position by inserting pins through the plates and the dollies. Close the pressure release valve on the pump body, then start pumping to push the former against the pipe. Turn the pressure release valve anti-clockwise to release the pressure in the hydraulic cylinder. When the arm has moved back about 6 mm to 10 mm, close the pressure release valve to hold the ram steady. Check both bends 90 degree and 120 degree by placing pipe on the layout. The next method we are going to see is hot bending method. Hot bending of pipes is a process in which a pipe is heated and then bent to a desired shape. This process is often used to create custom pipes for a specific application. The pipe is first heated to a temperature that is above its recrystallization temperature. This temperature is usually between 800 and 900 degrees Fahrenheit. The pipe is then placed in a jig or fixture that will hold it in the desired shape. File the pipe end square. Remove burrs. Calculate the length of pipe.
If D is equal to diameter of bend, theta is equal to angle of bend, L is equal to length of curved portion, then L is equal to pi into D into theta divided by 360. If OA is equal to inner radius of bend, R, AB is equal to radius of pipe, R, OB is equal to radius of bend, R plus R, then L is equal to R plus R into Q into 0.01745. Total length of pipe is equal to L1 plus L2 plus L.
Measure and mark off the center of the bend, beginning and end of the bend from the center line. Plug one end of the pipe with a wooden peg. Measure the inside diameter of the pipe and select two suitable wooden pegs for the pipe. Fill the pipe with clean, dry and fine sand. Compress the sand by tapping the pipe up and down with a soft hammer and plug the end. Ensure that the entire pipe is filled with sand. Clamp one end of the pipe in a vise and protect the clamped portion of the pipe with lead or copper shims. Heat the area to be bent with oxyacetylene torch evenly until it glows dull red. The bent area should not be overheated. Pull down the pipe gently in the direction of the bend. Take short pulls until the correct bend angle is reached. Check the bend radius with a template. Apply heat throughout the whole operation and overbend slightly and straighten out the final bend. Remove one end of the plug. Note: ensure that the pipe is cooled before removing the plug. Remove the sand by tapping the pipe gently with a hammer.
Let's have a recap of what we have learned today. We have learned to bend GI pipe by coil method as per template on a pipe bending machine. Bend GI pipe by heating and match with template. Thus, we have learned how to bend pipes using hot and cold method. Hope you have a clear understanding on this. Do this exercise with the help of your instructor. Hi, my name is Deepthi. A globe valve is a shut-off and regulating valve used for controlling the flow of liquid or gas in a pipeline. Sluice valves are used to control the flow of water in irrigation ditches, canals, and other water conducts. Stopcocks are used to control the flow of water in household plumbing. Today, we are going to learn about how to dismantling and assembling of globe valves, sluice valves and stopcock.
At the end of this demonstration, you will be able to dismantle and assemble a globe valve, dismantle and reassemble a sluice valve, gate valve, dismantle and assemble a stopcock. Tools required: spanner, screwdriver, file, hacksaw, hammer, pipe wrench, pipe die set, adjustable spanner, pliers, soft hammer. Equipment required: pipe vise, bench vise, oil can. Materials required: stopcock, union, thread seal material. Now, let's have a look at the parts in the following components. First, we'll look at the parts of globe valve. Globe valve. Hand wheel or key. Shaft of spindle. Packing nut, gland nut. Stuffing box with packing. Bonnet. Thread portion of the spindle. Metal valve or metal disc with rubber washer. Inlet. Outlet. Valve seat. Globe-shaped body. Now, we'll look at the parts of sluice or gate valve. Sluice or gate valve. Hand wheel or key. Shaft, spindle. Packing nut, gland nut. Stuffing box with packing. Bonnet. Screw adjustment. Seat and disc gate. Flow of water. Now we are going to see the dismantling and assembling.
Shut off the water by closing the main valve. Close the gate valve and remove the wheel nut with a spanner.
Remove the gland nut from the bonnet. Clean out the old packing in the stuffing box. Remove the bonnet with a spindle from the body and clean all the parts. Coil the asbestos rope, smear it with water pump grease and push it down with a screwdriver. Assemble the spindle gate to the bonnet. Assemble the gland nut, hand wheel and tighten the hand wheel nut.
Open the gate valve and tighten the gland nut until the packing is compressed sufficiently to stop the water escaping from the gland nut.
Note: do not use the gate valve to regulate the flow. It should be either in fully opened or fully closed condition. Clean the pipe joints free from rust and dirt. Loosen the union and separate the pipe joint. Loosen and remove the pipe nipple from stopcock. Loosen and remove the stopcock from the pipe joint. Dismantle the stopcock parts one by one systematically. Clean all the parts properly. Check the parts of thread. If worn out, replace with correct one. If it is in good condition, clean it properly and use it. Check the washer, whether it is damaged or in good condition. If damaged, change the washer. Reassemble the parts to ensure in good condition. While assembling the dismantled parts, last one should fit first and vice versa sequence. If the stopcock is in damaged condition, change it with new stopcock. Fit the stopcock to one end in lengthy pipe in the dismantled place pipe joint properly. Fix the pipe nipple to other end of stopcock properly. Next, fit the union with pipe nipple properly. Apply pressure and test the pipe joints and stopcock. Check for leakage, if any, to ensure proper working. Note: the arrow embossed on stopcock is to be in the direction of flow of water. Check the direction of arrow before fitting stopcock. Don't over-tighten stopcock and other pipe fittings. Use proper tools for dismantling and assembling pipe fittings.
Let's have a recap of what we have learned today. We have learned to dismantle and assemble a globe valve, dismantle and reassemble a sluice valve or a gate valve, dismantle and assemble a stopcock. Thus, we have learnt how to dismantle and assemble globe valves, sluice valves and stopcocks. Hope you have a clear understanding on this. Do this exercise with the help of your instructor.
Hello. Welcome to the session on performing routine check of machine and do replenish as per requirement. Let us look at the objectives of this session. At the end of this session, you will be able to check the running condition of lathe machine, check the oil level, check the sliding movement. The tools and materials required to perform routine check of lathe machine are lathe machine, lubricating oil, coolant, electricity tester, screwdriver, dial indicator, gun oiler, spanners, wrench, Allen key, kerosene, bunion cloth, safety goggles, gloves, in order to perform routine checks, turn off the power supply of the machine to avoid someone to use the machine during the maintenance procedure. Ensure to wear safety tools while filing cylindrical surfaces to prevent from injuries and also ensure a safe work environment. First, open the side cover and check driving belts if the belts are damaged or has excessive cracks and wear and tear. In such cases, they must be replaced. Check the tension of the belts. Check brake conditions if the lathe machines are with pedal brakes. Next, turn on the lathe machine and run the lathe for a couple of minutes. Check the level of lubricating oil in main gearbox visually. Refill the gearbox if required. While running, check whether all the automatic feeding movements are working properly. Check tailstock locking condition. Check whether both the levers locked properly. Check top bench lubrication manual pump. Pull or pouch lever to verify that the oil is coming to the sliding bench. Check the level of lubricating oil in lubrication tank. Then, check the level of coolant and refill it if required. Lubrication has to be done with gun oiler periodically. For headstock, lubrication is required for twice a year. On a daily basis, compound slides and tailstock nipple lubrication should be done by gun oiler. Lubricate apron and carriage using handle pump on daily basis. Also, lubricate change gear nipple, lead screw nipple and bedways by gun oiler on daily basis. Maintaining the coolant level is very crucial in lathe machine. Empty the coolant tank and fill up with new coolant as and when required. Wear rubber gloves to avoid contact with coolant during the refilling process. Before refilling, check the bottom of the coolant tank for any solids. If there is any solids, remove and always keep the coolant tank clean. Once the coolant tank is checked, run the lathe and test the coolant is supplied properly. Next, check the electricity supply. First, check the main power cable for its condition. If there is any damage, replace it. Verify the condition of all the external switches. If there is any damage, repair or replace it. Check the condition of all the limit switches. They must be strong in position, because a loose or damaged limit switch can generate a continuous fault on the machine. Finally, check the final point alignment. Once a year, verify the alignment of the center tailstock with the center of the headstock depending on the required precision. Here, alignment can be obtained by fitting a total parallel bar between the centers and by using a dial indicator to verify parallelism between centers. Let's recap the key points discussed. Turn off the power supply while performing routine check. Check the condition of belts, limit switches, lubricants, and all the moving parts for any damage. Check the level and quality of the coolant in coolant tank. Check the final point alignment. This brings us to the end of the session. Hope you have gained a good understanding about performing routine check of machine and doing replenish as per requirement. See you in the next session.
File and fit straight and angular surfaces internally.
Hello everyone. Today we'll be looking into the process of fitter practical sessions to file and fit straight and angular surfaces internally.
How to file and finish part 1 and 2 as per dimensions keeping straight. File angle tolerance of 10 minutes and angle face tolerance of plus or minus 0.02 mm. To remove internal material by drilling and filing. Tools and equipment required. Identify the tools and equipment used in fitter section. Record the names of tools, do's and don'ts of each tool. Record the names of the industries where the fitters are employed. Tools and equipment required. Steel rule, tri-square, scriber, dot punch, bench vise, flat file, triangular file, square file, vernier caliper, chalk powder, drill bit, bevel protractor, hacksaw, hammer. Safety precautions in fitting. Demonstration activities, shop talk with safety. Safety attitude development of the trainee by educating them to use personal protective equipment. Identify personal protective devices. Interpret the different types of personal protective devices. Eye protection, safety glasses, foot protection, safety shoes, dust and fumes, respirators, hands safety, gloves, head safety, helmet, hearing protection, earplugs, clothing, safety jacket, prevent from falling, safety harness. Check the raw material for its size. File to size and check for flatness and squareness. Apply marking media on the surface. Mark all dimensions and angle on workpiece using vernier height gauge and vernier bevel protractor. Punch on the marked lines. Drill relief holes of 3 mm on all corners. Remove unwanted internal material by drilling and using square and triangular files. Angular edges to be finished with triangular file. Straight edges to be finished with straight edge file. Part 1 to be finished to suit with Part 2. How to file and finish part 1 and 2 as per dimensions keeping straight. Part 1 and 2 for straight and angular surfaces fit in a sliding way. Check the raw material for its size. File to size and check for flatness and squareness. Mark all dimensions and angle on workpiece using vernier bevel protractor. Punch on the marked lines. File and finish the part as 28 into 25 into 40 millimeters and angle to 60 degrees. At the end of this exercise, you shall be able to assemble part 1 and 2 with a sliding fit part 2. File and finish the part as 28 into 25 into 40 millimeters and angle to 60 degrees. Assemble and check the finished parts. Recap. Tools and equipment required. Safety precautions in fitting.
Now you have learned how to file and finish parts as per dimensions. File angle tolerance of 10 minutes and angle face tolerance of plus or minus 0.02 mm. To remove internal material by drilling and filing. Hope you had a clear understanding on this technical process. Thank you.
Hello everyone. In today's video, let us discuss how to identify different ferrous metals using the spark test.
Objectives. At the end of this video, you will be able to 1. Support the metals on tool rest. 2. Grind the metals on wheel face. 3. Identify different ferrous metals by spark test. Let us discuss the machineries required to do this practical. Grinding machine, 1 number. Different ferrous metal pieces are used for grinding like cast iron, wrought iron, pig iron, low carbon steel, medium carbon steel, high carbon steel, stainless steel, high magnesia steel and tungsten magnet steel, each 1 piece. First, let us discuss ferrous metals. The term ferrous metals refers to those metals that contain iron. Ferrous metals typically rust easily when exposed to moisture because of their high carbon content. Numerous other alloying components such as chromium, nickel, manganese, molybdenum, and vanadium. Manganese can be used to create ferrous metals. Ferrous materials can be used for a range of engineering and non-engineering purposes, such as making tools, pipes, containers, cutlery, and larger constructions like skyscrapers. The fact that most ferrous metals are magnetic makes them ideal for use in electrical and motor applications. Your refrigerator door's use of ferrous metals enables you to use a magnet to attach your shopping list to it. Iron, cast iron, wrought iron, alloy steel, and carbon steel are some typical ferrous metals. Because of their tensile strength and longevity, these metals are highly valued. The longest and tallest bridges are made of carbon steel, also known as structure steel, which is a mainstay in the construction sector. Ferrous metals share some basic properties, including being prone to rust and being magnetic. The list of common ferrous metal properties include durable, good tensile strength, good electrical conductivity, low corrosion resistance, silver in color, recyclable. Non-alloy steels, also referred to as carbon steels, use carbon as the alloying ingredient. Other elements including manganese, silicon, sulfur, and phosphorus are present in these steels, but their concentration is so low that they have no effect on the material's characteristics. Non-alloy steels are divided into 3 categories based on their carbon content: low, medium, and high. Each category has unique properties and processing techniques. 1. Low carbon steel. Only 0.05 to 0.25% of the carbon in low carbon steels, commonly known as mild steels. These steels are frequently utilized for products like nuts and bolts or forgings because they are affordable and pliable. Carburizing certain steels can make their surfaces harder. 2. Medium carbon steel. Steels with a medium carbon content range from 0.25 to 0.6%. Compared to low carbon steels, this higher carbon content increases the strength and hardness of the steel. Nevertheless, these steels are less ductile than low carbon steels. Because medium carbon steels contain more carbon and manganese, they can be tempered and quenched. These steels are well suited for usage in railway applications, in addition to being frequently utilized to make parts for the automotive sector, such as gears, axles, and shafts. 3. High carbon steel. The strongest non-alloyed steels are high carbon steels, which have a carbon content of 0.6 to 1%. They are strong and retain their shape well, making them perfect for applications needing resistance to mechanical wear. The downside is that these steels are less weldable, ductile, and impact resistant than lower carbon steels. Spring, blade, rail, wire rope, wear-resistant plates, tools, and other items are made of high carbon steel. 4. Stainless steel. An iron alloy that resists rust and corrosion is stainless steel. It has at least 11% chromium and may also include other non-metals and elements to achieve other desirable qualities. The chromium in stainless steel, which creates a passive layer that may protect the metal and self-heal in the presence of oxygen, is what prevents corrosion. Let us do in practical. Step 1. Prepare the grinding machine for grinding. Step 2. Support the metals on tool rest or work rest. Step 3. Apply light pressure on the face of the wheel with metal. Step 4. Grind the metals on wheel face. Step 5. Identify the metal by spark length and color. Step 6. Grind the metal only on the face of the grinding wheel. Grind the following different metals and identify the sparks. Different metals: 1. Low carbon steel. 2. Medium carbon steel. 3. High carbon steel. 4. High speed steel. 5. Stainless steel. Let us discuss on spark test. Objectives: this shall help you to 1. Identify the spark testing in different metals by grinding. 2. Perform grinding process in grinding machines. It is a method of determining the general classification of ferrous materials. It normally entails taking a piece of metal, usually scrap, and applying it to grinding wheel to observe the sparks emitted. These sparks can be compared to a chart or to sparks from a known test sample to determine the classification. Spark testing also can be used to sort ferrous materials, establishing the difference from one another by noting whether the spark is the same or different. Spark testing is used because it is quick, easy, and inexpensive. Moreover, test samples do not have to be prepared in any way, so often a piece of scrap is used. The main disadvantage to spark testing is its inability to identify a material positively. If positive identification is required, chemical analysis must be used. The spark comparison method also damages the material being tested, at least slightly. Spark testing most often is used in tool rooms, machine shops, heat treating shops, and foundries. Process: a bench grinder is usually used to create the sparks. But sometimes this is not convenient, so a portable grinder is used. In either case, the grinding wheel must have adequate surface velocity, at least 23 meters per second, 4,500 surface feet per minute SFPM, but should be between 38 and 58 meters per second, 7,500 to 11,500 SFPM. The wheel should be coarse and hard. Therefore, aluminum oxide or carborundum often are employed. The test area should be in an area where there is no bright light shining directly into the observer's eyes. Moreover, the grinding wheel and surrounding area should be dark so that the sparks can be observed clearly. The test sample is then touched lightly to the grinding wheel to produce the sparks. The important spark characteristics are color, volume, nature of the spark, and length. Note that the length is dependent on the amount of pressure applied to the grinding wheel. So this can be a poor comparison tool if the pressure is not exactly the same for the samples. Also, the grinding wheel must be dressed frequently to remove metallic buildup.
In this video, we have discussed ferrous metals, their properties, types of ferrous metals, how to conduct spark test with grinding machines, identify the spark testing in different metals by grinding, and perform the grinding process in grinding machines. Thank you for watching. Have a good day.
Today we'll discuss a topic on firefighting pumps, installation and maintenance. Introduction. All buildings, depending upon the occupancy, use and height, are protected by fixed firefighting